Good afternoon, my dear students. So today in the sessions we are going to learn next problem on the helical spring. The first of all, I will read the question. One helical spring is nested. Another, the dimensions are as tabulated. Both these springs are having the same free length and carry a total maximum load of 2500 Newton. So in this problem, the tabular column is given here. The number of active coil of the outer spring is given as 6 and number of active coil of the inner spring is given as 10 and wire diameter of the outer spring is given as 12.5 mm and the wire diameter of the inner spring is given as 9 mm and the mean coil diameter of the outer spring is given as 100 mm and the mean coil diameter of the inner spring is given as 70 mm. So we need to determine the first condition, the maximum load carried by each spring. The maximum load carried by each spring we need to determine, and the second condition we need to determine is the total deflection of each spring we need to determine in this problem. In the third problem, we need to find the maximum stress in the two spring we need to find. So here the modulus of rigidity of the material is given as G equal to 83 giga Newton per meter square is given. Okay dear, so let us see. So first of all, write down here given data. So this outer spring is represented by O and this number of active coil is represented by capital I. Capital I is represent the number of active coil of the outer spring. How much is given here? 6 is given. Okay, as well as the number of active coil of the inner spring. The number of active coil of the inner spring is given as 10. Okay, and the wire diameter of the wire, this one, the diameter of the wire is given as the wire diameter of the outer spring is given as 12.5 mm and the wire diameter of the inner spring, it is represented by Di, it is given as 9 mm and the mean coil diameter of the outer spring is given as 100 mm and the mean coil diameter of the inner springs is given as 70 mm and the force is acting on each spring is given as 2500 Newton. Is it right? The first of all, in this case we need to find out the maximum load carried by each spring we need to find out. The first of all, we have to know that if any amount of compressive load is acting on the spring due to deflections is occurring in the inner and the outer spring remain same. Is it right? So let us see, sometime the deflection should be vary. Is it right? Y equal to, this Y is indicate that it is a deflection of the outer and inner spring. How much deflection is occurring on the outer and inner of the coil we need to determine. So Y is deflection equal to 8 is the constant. Fi nothing but internal force is acting on a coil. So Ci is indicate that it is a spring index of the inner active coils, and II is indicate that it is the number of active coil of the inner spring, number of active coil of the inner spring divided by G is indicate that modulus of rigidity of a material. Okay dear, and so Di is indicate that this is the mean coil diameter, or sorry, we can say as wire diameter of the spring equal to 8 into Fo. Fo is indicate that it is the outer force is acting on the spring. The Co is indicate that it is a spring index of a outer spring cube into Io. So Io is indicate that number of active coil in the outer spring by G is indicate that the modulus of rigidity, and Do. So what is the meaning of Do? The wire diameter of the outer of the spring. So this equation we have to take from the page number 139 and equation 11.5a from Design Data Handbook. Okay. So let us see. The first of all, in this case, what we need to find, because in this case here F is unknown value. Let us see. So in this case, which one is the unknown value here? Because the unknown value is Ci, is it right? Unknown value is there, and Co is the unknown value, and F is indicate that the total force is acting on the outer and inner of the spring, is it right? The Fi and Fo should be how much is given to, already is given here above. You can see total force F. How much is given? 2500 Newton is already given here. 2500. So this means that inner force plus outer force should be equal to the total force. How much total force is acting on the spring? How much is given here? 2500 Newton is already given. And Co, spring index at the outer of the spring, okay, equal to Do by small do, is it right? So let us see the do. This do is the mean coil diameter. How much is given here? Mean coil diameter is given as here 100 mm, and small do wire diameter is given as 12.5 mm. How much? 12.5 mm. If you divide the 100 by 12.5 mm, then you will get the spring index at the outer, you will get 8. If you want to find out the spring index at the inner, equal to same Di, capital Di by small di. So capital Di nothing but mean coil diameter. What we can say here? Mean coil diameter of the inner of the spring, and small d nothing but wire coil diameter of the inner of the spring, equal to small di. How much is given here? 70 mm is given, and capital Di is given as here 70 mm, and a small di is given as 9 mm. If you divide 70 by 9, then you will get the answer is 7.78. After the getting of this 7.78, this whole the value we need to substitute in the equation of 11.5a, page number 139. So let us see over here. So first of all, we need to here equate this equation. This 8 is as it is, Fi as it is, because we don't know the value of separate Fi, we don't know the value of separate Fo. But if you add that Fi plus Fo, then you will get the answer is, we know very well how much, 2500 newtons. So 8 as it is, Fi as it is, Ci value how much we got here? 7.78 we got. So here cube is there, you have to make as a cube, into I. So I, number of active coils of the inner of the springs, how much is given here? I is given above is 10. Okay dear, I is given as 10 by, so G is the modulus of rigidity, the same, because here also same is there, otherwise you can take the value, not a problem is there. The modulus of rigidity of the material, how much is given? 83 giganewton per meter square is given in this problem. So you can take here, otherwise you can keep as it is, because this G and this G will be cancelled. Is it right? Then after that, let us see DI value. DI, how much is that here? The DI value is 9, okay, equal to 8 as it is, FO as it is, CO value is 8 whole cube into IO is number of active turns of the order of the springs is given as 6 divided by modulus of rigidity as it is DO. Okay, the wire diameter of the order of these springs is given as 12.5 mm. So this G and this G and this 8 and this 8 will be cancelled. Again you need to cross multiply these terms. So here 8 cube into 6 into 9 divided by 7.78 whole cube into 10 into 12.5. If you divide this whole the value, then you will get the answer is 0.47 FO. So it is considered as equation number 1. After getting the equation number 1, we have to take this value F is equal to Fi plus Fo. Okay, so how much amount of force is acting on the inner of the spring and how much amount of force is acting on the outer of the spring, so we need to find. So how to find? F is equal to Fi plus Fo. Fi value already is given in the questions. How much is given? 2500 Newton is given. How much is given dear? 2500 Newton is given, equal to Fi value is how much is that here? 0.47 Fo. 0.47 into Fo plus Fo as it is. So in this case we need to add. So here if nothing will be there, means here should be 1 plus 0.47 should be how much? 1.47 Fo. Okay dear. After that, if you divide the whole the value here, 2500 here, 2500 divided by 1.47, then you will get the 1700.68 Newton. So this means that the load carried by outer of the spring, we got it. Is it right? The same thing we need to find out how much load carried by the inner of the spring, we need to find out. If you want to find out, you need to substitute the value of Fo in the equation number 1. In the equation number 1, then you can easily get the value of Fi, the load carried by inner of the spring. Let us see over here. Fi equal to the equation, what is the value? Fi equal to 0.47 F0. Fi equal to 0.4047 Fo. 0.47 as it is. Fo value is how much is that here? The load carried by outer of the springs. The load carried by outer of the springs is given as 1700.68 Newtons. So just you need to multiply 1700.68 into 0.47, then you will get the answer is Fi value is 799.32 Newton. So load carried by inner of the spring, the load carried by inner of the spring, how much we got here? 799.32 Newton we got it. Okay, after the getting of Fi and Fo, you need to find out the second condition is total deflection of each spring, we need to find out. So we have to take first from the first equation from here, this equation we have to take this one 11.5 page number 139, we have to consider here this one, y equal to deflection value, because we need to find out the total deflection of each spring, we need to find out. Y equal to 8 Fi into Ci into Ii by G into Di. So 8 into Fi, nothing but the load carried by the inner of the spring, into Ci, nothing but spring index of the inner of the spring, and the I's indicate that number of active coils. What we can say here? The number of active coils of the inner of the spring, and divided by G, nothing but the modulus of rigidity of the material, and Di, nothing but the wire diameter of the inner spring. So 8 as it is. Fi we got how much? 799.32. The load carried by inner of the spring, how much we got here? 799.32 into Ci, spring index of the inner of the spring. Ci already is given. How much is given here? 7.78 is given. So here cube is there, so I miss here 8 Fi Ci whole cubed here. Okay, so I will write this one. Here should be cube. Okay dear. Let us see. 8 Fi Ci whole cube into I by G into Di. So 8 as it is. Fi is the load carried by inner of the spring is given as 799.32 into Ci, the spring index is given as 7.78 whole cube into I is the number of active coils of the inner of the springs is given as 10 by the modulus of rigidity of the materials is given as 83 into 10 power of 3 into Di, nothing but the inner diameter of the coil. So how much is given? 9. If you divide the value with the help of calci, then you will get the answer is 40.31 mm. Is it right? After that, in the third case, we need to find out the maximum stress in the inner of the spring. We need to find out. If you want to find out the maximum stress in the inner springs, we have the formula. So what is the formula is that here? Shear stress. The shear stress is indicate that maximum allowable shear stress at the inner of the spring should be equal to 8 Fi into Ci into Ki by pi into d1 whole square. So in this case, what we need to find? We need to find out the value of Walsh factor. This is the Ki is indicate that it is a Walsh factor we need to find. The Ki is equal to 4 into spring index at the inner of the springs minus of 1 divided by 4 into spring index of the inner of the springs minus of 4 plus 0.615 divided by spring index of the inner of these springs. So in this case, 4 is constant. Ci value already we got it. How much? 7.78 minus of 1 divided by 4 into 7.78 minus of 4 plus 0.615 divided by 7.78. If you divide this whole the value, then you will get the answer is 1.1897. So after the getting of the Walsh factor, you need to substitute in the maximum allowable shear stress in the inner of the springs. So in this equation we need to substitute. So tau I. So tau I is indicate that maximum allowable shear stress is acting in the inner of the springs. Tau I equal to 8 is as it is. Fi value is how much already we got here? 799.32 and Ci value Ci already we find how much dear? 7.78. and the K value, the K is indicate that it is a Walsh factor. How much we got here? 1.1897 divided by pi is constant value 3.142 into Di value already we know very well. How much is there? 9 whole square. If you divide the whole the value, then you will get the 232.71. The unit is Newton per mm square. That is the value of maximum allowable shear stress in the end of these springs. As well as same thing, we need to find out the maximum stress, maximum allowable stress in the outer of the springs we need to find out. If you want to find out the same formula we have to use, just we need to change only, instead of Fi we have to replace the Fo, instead of Ci we have to replace the Co, instead of Ki we have to represent the Ko. Is it right? So instead of Di we have to represent as Do. The same as it is formula we need to follow. Is it right? And Ko, the Walsh factor of the outer of these springs, equal to 4 into spring index of the order of the springs minus of 1 divided by 4 into spring index order of the springs minus of 4 plus 0.615 by CO. So 4 is as it is. CO value already we got how much? 8 minus of 1 divided by 4 into 8 minus of 4 plus 0.615 by 8. If you divide this whole the value with the help of calci, then you will get the Wahl's factor is 1.18. How much dear? 1.18. So maximum allowable shear stress in the order of these springs tau O equal to 8 is as it is, and FO value is 1700.68 into CO value is 8 and KO the Wahl's factor is 1.18 divided by pi into 12.5 whole square. If you divide the whole the value with the help of calci, then you will get the answer is 261.78 Newton per mm square. You will get the answer. Okay dear, I hope so no one is having the doubt regarding this session. If you have the small doubt regarding this session, please write down in the comment box, and please don't forget to subscribe my channel. Thank you dear.